Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. I2NiHCO3 is the classic iodolactonization condition. NiHCO3 is a mild base that deprotonates the carboxylic acid to form the carboxylate nucleophile in C2, while I2 acts as the electrophilic iodine source. Moving on to the next step. The starting material is a cyclohex 2Na-bearing A, CH2Co, acetic acid, side chain at C1 with specific stereochemistry, H, and the side chain both on wedge bonds at C1 indicating a defined stereocenter. The double bond is between C2 and C3 of the cyclohexene ring. Moving on to the next step. I2 activates the double bond by forming an iodonium ion, cyclic, bridging C2, C3. The carboxylate oxygen, acting as the intramolecular nucleophile, attacks the iodonium ion from the back side, anti-addition, SN2 type. The carboxylate attacks the more electrophilic carbon of the iodonium, the more substituted or geometrically accessible carbon, forming a 5-membered, gamma, or 6-membered, delta, lactone ring. With an acetic acid side chain, CH2Co, at C1 the oxygen is 2 carbons away from C1 and C2 is adjacent to C1, so attack on C2 gives a 5-membered lactone, gamma-lactone, deuterolactone ring fused to cyclohexane. And for the final step, the iodonium ion forms on one face of the double bond. Anti-addition means I ends up trans to the lactone oxygen. The product is a bicyclic compound, a cyclohexane ring fused with a 5-membered lactone ring, with I on the IChO axial position and the ring junction stereochemistry as shown in option B. NiHCO3 does not convert the lactone to a sodium salt under these mild conditions, the lactone ring closes spontaneously. Option A shows a diodide with sodium carboxylate and intact double bond. Incorrect. Iodolactonization gives one I and a lactone, not 2 iodines. Option C shows an alpha-iodo acid with intact double bond and no ring closure. Incorrect. Iodolactonization proceeds with ring closure under these conditions. Option D shows a sodium carboxylate with iodine and an intact double bond but no lactone. Incorrect. The carboxylate nucleophile closes the ring to form the lactone. Option B correctly depicts the bicyclic iodolactone product with anti-stereochemistry, I and the lactone oxygen on opposite faces, consistent with the iodonium ion mechanism. Therefore, the correct answer is B. Therefore, the correct answer is option B.